So I'm going to try to show you how to create a one-point perspective grid on an 18 by 24 piece of paper. The first thing we're going to do is divide up the bottom margin of the paper by inches. So get a ruler, preferably a 24-inch ruler. Make sure that it is flush with the ends of the paper or zeroed out at the end, and you're going to make a series of short marks like this at each unit on the ruler, each whole unit. Please make these marks very short. I'm making them a little longer than they have to be just so you can see what I'm up to. But you'll get confused if your marks go up too high. And that takes us all the way to the end with a full unit, full inch unit at the end. Next step is to create a horizon line. It should be 12 inches from the bottom of your paper. That's arbitrary. We just picked the number 12 because it's easy to divide in half. And then you're going to take a T-square, which looks like one of these, and make sure that it is gliding flush with the edge of your paper. And you want to go up to the little mark you made. Make sure your paper's taped down before you do this. Tape it down true to the board. And that's your horizon line. Next step is to mark the center of your horizon line. It really doesn't have to be exactly in the middle, but I'm going to put it in the middle this time, right at 12. That's going to be the vanishing point, the single vanishing point for one-point perspective. Then we're going to simply connect from the vanishing point first to the corner of the page. Okay, we're going right dead into the corner and very lightly like that. Then I go back, pivot my pencil around the vanishing point, and I'm pulling down to the bottom of each one of these marks. I hope you can see that. I'm sure my arm's kind of in the way right now. I'll zoom in on some in a second. So I can also pivot around this point like that. And the most important thing here is that you make these lines very faint. And that's because this grid is going to be essential for measuring the height of objects that we put on it and locating their footprints. But our finished drawings are not going to be drawings of grids, they're going to be drawings of objects. So a lot of this grid is going to have to be erased. As I said, I'm going to zoom in. Well, you know what? Maybe I'm not, because you're not going to be able to see the what I wanted to show you. So we're just going to leave it out like that. Just threw it out of focus. Okay. So the things that sometimes go wrong, aside from pressing too hard, is forgetting to do the lines that go all the way to the corners. So don't forget those too. And as far as pressing too hard, I want you to understand one really important thing, which is that if you are gripping your pencil hard, you're going to naturally make a very dark line. And if you grip your pencil very lightly, you will naturally make. So the reason for that is you don't have any nerve endings at the end of the pencil. Your nerve endings are in your fingers. And if you grip the pencil too hard, you can feel that. If you're pressing too hard on the paper, you don't feel it. You just notice that your drawing is way too dark, and that's not good. So hopefully you can see that the fact that these little marks at the bottom are really short makes them it's easy to aim for the right part of the mark. Sometimes students make really long lines at the bottom, and then they start aiming for the wrong part of the line, which is not good. So that's our original fan of orthogonals. These lines that go to the vanishing point are called orthogonals. And we're going to talk about a little geometry thing, which is similar rectangles. If you take, similar triangles, excuse me. If you take a triangle like this, which we've just created, and you cut a section out of it, this triangle up here becomes the same proportions as the triangle that we cut it out of. So these are called similar triangles. The rule in geometry with similar triangles is that if you cut the height of this triangle in half, which is about what I did, then the base is also going to shrink by the same amount because they're similar, they're the same proportions. So if we cut the top half off this triangle, we've reached a point where the base is going to be exactly half as wide as this base. And if you can recall that there were 24 units down here, and they were 1 inch apart, and you realize that this is now half as big but has the same number of units passing through, then you can see up here we have 24 units, but they're going to be half as big, so that's going to be at half an inch. And the reason that's convenient to understand is because we're going to now add more more orthogonals to our fan by creating a horizontal up here. So as you guessed, we're going to go 6 inches from the bottom, or 6 inches from this line. Right? It's going to be the same amount either direction because the line was 12. And we're going to put a very light horizontal across there. And as you can see, this section, the base of this triangle, is now exactly 12 inches. And that means the units here are now half an inch. So I'm going to very clearly mark this dot, and I'm going to add some more dots going by half inches this time, like this. And then I'm going to do the same thing on this side. Only I'm going to line up my 6 right here on that corner, and then I'm going to go by half inches to the left. And what that creates is a doubling of the number of orthogonals that we have in our grid. So I'm going to quickly add these. think you've seen me do enough of these for me to pause. And that's the entire fan. You see it goes from here all the way to here. Now, there's a really important idea that we're going to talk about for just a minute. And that idea is foreshortening. What we're trying to create is a drawing of a grid like this. Notice that looking down on this grid, each square is a square. It looks like a square. In other words, the height and the width of each box are the same. That's because the camera lens is pointing straight down at it to a 90-degree angle. There's no foreshortening. If we tilt the grid like this, see what happens? The spaces between the orthogonals, the lines that are going away from us, stay about the same, although they start converging. But the spaces between the horizontals going this way become relatively short. And that phenomenon is called foreshortening. We don't tend to notice it because our brains are used to adjusting for it. But if I show you a pencil like this and then I tilt it up towards you, nobody thinks I've done like a magic trick and made the pencil suddenly smaller. You can just see that it's now occupying less room in the camera's field of vision because it's pointing at the camera, and it's more room if it's not pointing at the camera. So what this all means for us is that if we were to do what a lot of beginners do and just measure up 1 inch and then go across like that, that would not look to most people like we had drawn a square. Are you able to see that on there? Hang on. That's better. See, that does not look to most people like a square. That looks like a drawing in perspective of a brick or rectangle. And you'll see it looks nothing like one of these because it's just too deep front to back. It's not foreshortened. A foreshortened square is going to look approximately 1/2 to 2/3 that wide, sort of like that. And that looks like a square to most people because, again, we're used to living in a world where things are foreshortened. So the next step for our grid is going to be, we're going to go from this corner down here, lower left, through this dot that I asked you to make. Now, if you have a hard time finding that dot, it's the point where this orthogonal, which goes to the corner of your page, intersects this horizontal, which we made at 6 inches from the bottom. So we're going to simply draw that. And that gives us a nice height for our first square. Let me get my T-square and show you what I mean. See, this looks to most people like a square on the floor, which is what we're going for. Hopefully you can all agree with me on that and see that the shape of that is similar to this shape. You see that? So the really cool thing about grids, cool if you don't like to do math, is that even though these are going to be diminishing at a constant rate that could probably be calculated with some kind of algorithm. Convenient for us, if you've done a line that goes through one corner on a grid, it's going to also go through all the other corners on the grid as far back as you want to go. You could keep doing that forever. So that means if this diagonal looks good to us, in other words, if this first one looks like a realistic square that's consistent with what we're going for in this drawing, we can use that to create our entire first row like this. But we can also use it to create the second row. Because see, there's the next intersection on the grid. So that's the second one. And look, we can keep going. And the only tricky thing here is you've got to pay attention now if you're using a T-square. Make sure that T-square's head is always snug up on the side of the board, because if you let it drift like this or like this, see what happens? It's not horizontal anymore. So what I'm doing is I'm putting my pencil down on each intersection, sliding the T-square down until it just lightly touches my pencil, and then I'm lightly pulling my lines to the left and to the right, like this. And I'm going to keep doing this until I get all the way to the top. And notice the higher we get, the closer these are together. This is the line I already made. That was my half-inch line. So we're only halfway up the grid, and look how close together these lines are. Now, if you think about it, these lines are going to keep getting closer together so that when we get near the horizon, it's just going to be black. We're not going to have a grid anymore because our pencil lines are way thicker than the spaces between them are going to be. So we're going to have to stop sooner or later. But I like to have students reflect on the notion that, you know, some people just want to take the 1 inch width and go up and maybe start making horizontals every inch. And if you think about it, that would get us to only 12 horizontals between the bottom of the picture and the horizon line. So we'd only be able to build objects there that were, we'd only have 12 inches of space to build objects. And I like to ask students, how far away is that really, that vanishing point? And the best answer is just really far. Remember, the horizon line on Earth reflects the curvature of the globe. So when we look at the horizon, it's only about, I forget, was it 20 miles away, 25 miles away, maybe less. But this is not a curved surface, this is a geometric plane. So this point where the lines meet is actually an abstract idea. Like, they're never actually going to touch. So that point is technically at an infinite distance from where we are. Don't think too hard about that, though. Just understand it's a really, really far away. When you run out of ways to make lines there, you can always add more orthogonals by choosing a different unit. I'm going to show you a little hack just to add a few more. You can use a piece of scrap paper and without using math. You just mark off about how far apart the orthogonals are and transfer those units onto your last horizontal. And then you can add more horizontals, like more orthogonals like that. And if I had done that on the other side, I would also now be able to add more horizontals as well. I'll go ahead and do that because you can just fast forward if you don't like this. So the units I just made will work on either side. So I'm going to take them over here and transfer them. So that last horizontal that I made. And how big are those? What's their distance apart? I don't really care. I just want this to be approximately correct. And now I'm creating orthogonals that are going to go through that diagonal I already made. See that? I can even extend it slightly. And that'll give me a few more horizontals on my grid. You don't have to do this, but it's good to know that you can theoretically just keep extending your grid back until, as I said, the space between the lines becomes smaller than the lines themselves. So that's our one-point perspective grid. In the next lesson, we're going to talk about how to build objects onto it. Thanks a lot.